69% are paying more attention to energy efficiency than they were a year ago. This one's kind of interesting. 44% will accept paybacks greater than 3 years. There's this folklore, and I don't know if it's folklore or not, but there's this general feeling that investments in manufacturing are okay if they're 2 years or less. We hear that an awful lot. Well, the survey said that 44% would accept paybacks greater than 3 years, and another 41% would accept paybacks between 2 and 3 years. That's over 80%, all right? Again, kind of curious. In your organizations, would you invest in energy efficiency with a high degree of reliability and performance if it had more than a 2-year payback? How many of your organizations would? Show of hands. All right, how many wouldn't? Absolutely not. Okay, it's interesting. So it looks like the survey probably reflects the majority. Finally, 22% organizations allow longer paybacks than 5 years ago. Think back 5 years in your organization. You talked to the CFO to try to get some money for energy efficiency. 22% said that the payback criteria would be longer today than it was 5 years ago. All right, going in the direction of more investment. Only 9% said they allowed longer paybacks 5 years ago. Some of you are in some industries that are a bit distressed or certainly under pressure. Still, investment in energy efficiency, big priority. Okay? Now, we have just run the survey again, and we have a lot more folks from the manufacturing sector. We're going to be announcing the results in a week and a half. So if you're interested, the results of this year's study will be posted. It'll be fascinating to see if this has changed significantly over the last year. Okay? So that's sort of our little backgrounder. This is our favorite question. We asked, what was their motivation for investment in energy? Is it purely cost savings? Is it driven by $100 barrel oil? Or is it environmental stewardship? Is it social responsibility? Is it that? We were shocked in that 48% of the participants in the survey felt that environmental responsibility was at least as strong a motivator as cost reduction. Hard to imagine 3 years ago that would have been the case. It'll also be fascinating to see if that increases over time in this year's survey. Okay? So, let's talk a little bit. When people talk about investing in energy efficiency from an environmental sustainability perspective, generally what people are talking about doing is reducing greenhouse gases. How many of you talk about greenhouse gases within your operations organization back home? Okay, interesting. A lot of hands. If I had asked that 2 years ago, don't think so, right? So this is now becoming important because of climate change and global warming and things like that. Manufacturing actually contributes a fair amount to greenhouse gas production, and it does it through 3 principal ways. The most direct way are called direct emissions, and that would be the use of gas and other greenhouse gases within the manufacturing facilities. Carbon dioxide is what everyone talks about. They talk about carbon reduction. Carbon dioxide is really just used as sort of an equivalence to a number of other gases like methane, SF6, and other things that may or may not be used in the manufacturing operations. Okay? Number 2, and generally the highest amount of greenhouse gases aren't actually produced within your plants. They're actually produced by the power plants that make electrons which go into your plants. Okay? Depending on whether this is a coal-fired power plant or whether it's hydro or nuclear or something like that, has a big factor on whether your plant is actually creating greenhouse gases through use of electricity or not. Depends where you are in the country. And then finally, there's this really gnarly thing called Scope 3. These are all the greenhouse gas emissions from your supply chain. Everything from the trucks that deliver your materials, to waste management, to air travel for your employees. This can be very, very significant depending on your organization. A lot of retailers like Walmart and others are really trying to focus on the supply chain to reduce their environmental footprint. So, when Johnson Controls looks at our energy efficiency, it's really being driven to reduce greenhouse gases as well as reduce the cost of our products and our operations. So what we've done is we've been tracking this very diligently for the last couple of years. This is our United States greenhouse gas emissions from 2002, the first year we have accurate baseline data. And what you'll see is from 2002 to 2006, our absolute greenhouse gas emissions reduced 1%. And that doesn't sound like a lot. Meanwhile, our revenue has increased tremendously within the United States. So it's actually a good thing to hold your emissions constant while your revenue goes up. Greenhouse gas intensity is really the amount of greenhouse gases emitted divided by your revenue. So if you can hold greenhouse gases constant, increase your sales, the intensity, or the greenhouse gases per $1 million sales, actually goes down. And as you can see here, we're down about 12% after 4 years. We've actually established a goal of reducing our greenhouse gas emissions by 30% over 10 years. And so that's 2002 to 2012. And we didn't just keep it a secret. We felt that an internal goal was good, it could drive change, but then making a public declaration of the goal and actually being audited by the US EPA as part of their Climate Leaders program was a really great way of rallying the troops. For the first 4 years of the program, it was an internal goal. As soon as we committed publicly to actually meeting this commitment, it was amazing how many times our presidents had to report to the CEO and to the board of directors on our progress towards this goal. So that's one of the key lessons that we have learned. Now, we're not going to achieve this by just moving manufacturing outside of the United States. We also track greenhouse gas emissions on a global basis. And actually, outside of the US, we've even reduced greenhouse gases more. So if you were to plot the same chart through 2006, we reduced 24% on a global basis. Okay? Question?
Are your plants outside the United States newer?
Yeah, they tend to be newer. We create standards around energy efficient lighting and equipment and things such as that. So one of the advantages in the newer plants is they're built to a higher degree of energy efficiency. Also, revenue is increasing tremendously outside the U.S., so that affects both there. Actual energy use is going up outside the U.S., but the intensity is going down due to the efficiency of the equipment. Okay? So, my last slide before I hand it off to Kevin is just a restatement of kind of our goal. This becomes very important, actually. This has driven so much improvement across the globe that it's hard to understate that. Our operations groups are committed to develop a plan at a plant level of how they're going to reduce absolute emissions 1% and how they're going to make up the other 2% per year through revenue increases. We also have two other environmental strategies, one around development of green products, getting the revenue or the profit side of the equation, and also greening our supply chain. At this point, I've kind of set up why we're interested, what we're doing, and I'm going to turn it over to Kevin, who can explain to you in gory detail exactly how we go about getting the reductions that we have. Thank you.
Thank you, Clay. As mentioned before, I'm Kevin Shelton. I'm responsible for executing a lot of the strategies or developing the strategies for them to be executed for the organization. I've been working in the industrial marketplace for about 25 years and involved in energy reduction programs along that time. How many people in this room are either running plants or have responsibility for operational budgets or plant budgets? Good. So I'll be addressing the majority of this to you folks that are sitting in the room. I was thinking back when we were talking about payback criteria, and I've been working associated with the automotive industry for a long time. About 10 years ago, I recall that we had some initiatives to try to establish some partnerships with the automotive company because as a part of the building efficiency group, we provided services. We also had a large automotive presence. So we were talking with the major 3 automotive companies here in the U.S., General Motors, Ford, and Chrysler, about energy reduction programs. And they were very interested in doing things, they were very interested in reducing their costs associated with that. And when it said, okay, so what's your payback criteria to make these investments? And they ranged from 4 months to 1 year. So after spending a little bit of time with them, I decided I'd be better off spending my time someplace else. That's really changed today. One of the announcements that just came through 3 times in my email yesterday was Nissan as a global automotive manufacturer, is now requiring all of their tier 1 suppliers, so the major suppliers, which Johnson Controls is one, to report out on their progress on greenhouse gas reductions on an annual basis to their senior leadership in Tokyo. So Clay talked earlier about the press, the presence that was going on, and what's happening now is companies are actually actioning it. So you saw the commitment that Johnson Controls made to this, and timing is good because now our customers are requesting this of us. We talk about the manufacturing footprint. We are a global organization. My responsibilities for the broader organization in terms of real estate, construction, and facility operation are in the Americas. But as of Monday, with some of the announcements, I have now responsibility to pull together the greenhouse gas information, working with Clay and the rest of his organization for our automotive businesses, our building efficiency business, and our power solutions, because it's becoming increasingly important to our customers. So we'll talk a little bit about what we've actually done and how do we get to this. So there's a few major points I want to talk about. Making a commitment to reductions. We talked about our corporate commitment. Setting a baseline with current performance data. So you have to know where you're at to be able to measure your progress. Setting tangible goals, and you heard that, 30% reduction over 10 years. And that's even trickled down to direct goals that each of our business units presidents have in terms of 1% absolute reduction and 3% reductions per year. Documented with baselines, action plans, and strategies put in place to actually get there. So this is a major shift even for ourselves as a manufacturer. Developing the plan, executing the plan, measuring the results, and recognizing the achievements. Let's talk a little bit about what we do here. We talked about the commitment to energy. Clay talked about the announcements that we've made in the press and to the general public, and this is a reiteration of this that goes to every employee that Johnson Controls has worldwide, as well as it's posted on our portal and our webpage. It's available to the public. One of the questions that didn't get asked when Clay was up here, he talked about the survey results for manufacturing being posted. Where are they going to be posted?
On our website.
Okay, so on jci.com, we'll be able to find it there.
Kim,
yes.
You talked about those goals that your different business units have been given, and the funding is their responsibility out of their operating budget.
That's correct. Well, operating and capital. It's their responsibility to find the funding to achieve the goal within their business plans. Okay, so we'll talk about that in a minute also on the funding of this. Just general data. $223 million, a significant portion of our overall costs go to energy. That's primarily related to our internal costs, and Clay, do you know if that includes our costs of our trucking companies and our shipping companies as well?
No, it does not include transportation.
It does not, which is a significant cost that we incur and a significant contributor to greenhouse gas. So we talk about energy management leading to sustainable results. So many of you have dealt with energy in your plants and your operations. There's three basic areas that we find the opportunities for savings. The rate. This is what do you pay for your utilities. Many of you may feel we don't have a choice. I mean, I've got the electric lines coming in, I pay my bill, whatever they do with the rates, I'm pretty much helpless on that. But actually, given deregulation in many parts of the country and in many markets, you do have the opportunity to go and negotiate those rates. And you can either do that yourself, or there are other companies out there in the business to help you do that. The next area is utilization. And that's kind of tied to efficiency as well, and that's how do you actually use the utilities that are coming into your operation, and then how efficiently do you use it once you have it there. And we'll talk a little bit about what those two things are as well. The basis for our success in achieving these objectives is a programmatic approach to energy. We have a program management, so I have managers and groups of people that are responsible for developing the projects, implementing, reporting them, and I'll talk about the process that we go through. But when we talk about tactics, we talk about a couple things. Supply side management, that's how do we buy the power. Demand side management, how do we use it, how do we lower the amount that we use. Utility bill management, this is kind of like a little hidden opportunity that we found, is that there are tremendous errors in billings from the utility companies. They may have you on the wrong rate, you may be able to save money just by changing the number of meters you have, so that's another great area of savings that's available to you. Energy information. Again, if you don't have the data, you can't really understand how to go about reducing it. And then finally, regulatory compliance. This is something that we all have to do, and this actually tends to be the one area that folks have been focused on for a number of years, complying with governmental regulations, safety regulations, and a lot of our activities have been driven by those. We talk about energy measurement. The question says, well, how do we do it? Where? There's a number of ways. Let's talk about these individually. At the plant level, right, we measure the cost and consumption. Per equivalent unit just says we're going to take the amount that we spend in each of our utilities, we're going to divide it by the number of widgets that we put out the door. So for example, in a battery plant, each of our battery plants can tell us how much energy it takes to build, that goes into the cost of the battery. So then they can also put some goals around how do we reduce that cost for each of ours, which kind of drives us into start looking at opportunities. The next level is at the business unit level. And that's where we may have 28 automotive seating manufacturing plants, and they measure by equivalent units, but now we have the ability to compare their utility data across all 28 plants. So why is one plant using 50% more than another? How does that impact the cost of a seat? And so it gives you the opportunity to start saying, where are there additional opportunities to capture best practices? The next is at a corporate level. How do we report overall performance as a metric using revenue to account for internal growth? And you may be saying, well, how did you go from dollars or kilowatts to revenue as a means to measure? Well, we happen to be a diverse manufacturer. We manufacture a lot of different things, and it's hard for us to come up with one unit. So measuring it as a percentage of revenue, it allows us to do two things. Number one, measure our progress, and the second, it also accounts for the growth of the company. As your sales increase, as you may acquire other companies, as the business metrics change, it's a consistent unit of measurement. So what does this do for you? It provides the ability on the plant level for a local focus, because you can watch a utility bill each month, and you can start tracking year-over-year performance. Yes?
How do you, if you increase your sales prices and it increases at a higher rate than your energy costs, how can that be a matrix?
In our case, it just happens because the pricing varies on our products, and we have price increases in a number of things also as we have utility cost increase. It still provides us a benchmark that we can use on a more consistent basis, because your price increases versus the cost of utilities isn't going to have a dramatic impact when we report that out. By the time we do the division, the utility cost per unit or per sales dollar tends to be small variations. BDP analysis is best business practices. And that's simply saying if you divide up the amount of costs that you have across a given category, you can compare them across various locations that you may have. It lets you say, well, who's our best plant in this area, who's our highest plant in this area, and begin to start a dialogue between them. Say, why are your costs so much lower than ours? What are you doing that's helping you to be successful? And transfer that internal knowledge between your own organization, within your own organization. And then the benchmarks, again, gives you a way to continue to have the baseline and measure progress. So what are the typical energy improvement projects that we see in a manufacturing environment? These are kind of the standards. Compressed air is a huge energy user in the plant. Steam systems, if you're using steam in the process, very costly. Big consumer of natural gas. Lighting is one that everyone has, and actually is a very good opportunity using technology to drive reductions. Motors, variable speed drives, waste heat recovery, HVAC and refrigeration, and then as you move into your specific manufacturing processes, you may have other pieces of equipment or technologies that consume a lot of electricity and go from there. Yes, sir?
I know it's not one of yours, but water is another big one that a lot of
Yes.
companies are focusing on.
Yes, so water is another important component as we look at sustainability and cost of operation. Okay, so the implementation process. This is, you've heard of the 11-step program. We have the 18-step program. Being a large organization, Well, let me ask the question, how many of you can have easy access to money for improvements that you want to make? Okay, I see a few of you. You're probably in decision-making roles on where your monies are spent. How many of you have to make decisions on what capital projects you're going to spend your money on? Right? So you've got multiple projects competing for the same piece of money that you get. So these are some of the challenges that you face. So the implementation week process that we go through, I'll explain that. First, we do a plant audit or a survey. We want to know what's in our plant, what's consuming the biggest amount of electricity, and where are there opportunities for savings. Once we identify an opportunity for savings, we then develop an application or choose an application. So let's say we decide that we're going to focus on lighting, as an example. So then we'll say, okay, we're going to look at lighting because in our case, although it has an impact on an individual plant basis, when you multiply that across 50 plants, the impact becomes very large. Then we go do a technology analysis. So we say, okay, yeah, we have to have lights that are consuming electricity, but what are my options? And so that's when you start getting into an investigation of what are the multiple lighting technologies that are there, what's the benefit associated with those, what are my specific needs, do I need specific light levels for my operation, and get into detail at the plant level. I may not need the same level of lighting in my warehouse as I need if I'm doing a technical assembly. So I'll let you become very specific there. Based on that, we then calculate cost reductions, and that can come in the form of energy consumption, maintenance costs, and state and local government incentives. I mean, how many of you are aware that there's a government program right now that provides tax credits for investments in energy technologies? Okay, so there are funds available for that also, and I'll talk about that a little more later. Then we calculate the greenhouse gas impact, because for our organization it's important that we measure that and document the results. We calculate a return on investment. Right? How many of you can make investments without providing any kind of financial impact? Okay, so I see one. Again, a discretionary spender. Based on that, we project the impact by the site. So on an individual plant basis, we give analysis of what that opportunity is by plant, and then we aggregate those to say what's the impact on the organization. So in this case, if we're talking to somebody like the Vice President for North America running our automotive business, and he's got a $1.5 billion budget, to tell him we can save you $20,000 in a plant on electrical costs may not necessarily have a lot of impact on him. They'll say, we'll go talk to the guy in the plant. But if I turn around and say, I can reduce your cost by $2 million across your portfolio by implementing this, now I have his attention. So that's where scale becomes appropriate. So in this case, we present the information and we gain preliminary approval from, in this case, that executive to go ahead and fund some of the projects. So we select pilot sites. And in our case, because we have diverse operations, we typically identify 1 to 2 plants from each different business type based on some of the return criteria that we get. We fund those improvements, and we actually go and we establish the baseline first. Here's what we're spending and consuming today. We implement the project, and then we measure the results of the project. So now we know what we thought it would do, and we have the means to measure what it actually did. Based upon the actuals for those pilots, we go back and redo the calculations for the impact across the organization. And in many cases, then you have hard data that says, we tried it, it works, now let's go do it across the rest of the organization. Here's what you're going to get, here's what it's going to cost. In our case, Johnson Controls spends capital to fund these improvements in the manufacturing process. And so we prepare a capital appropriation request, which talks about the description of the process, why we're doing it, what the alternatives were, including not doing anything, in order to support the recommendation to spend the money. Then there's the financial return, and now we've recently added greenhouse gas impact to that, because being people that have to implement stuff, we know that the way to do that is to make sure that we provide the data that's important to the people making the decision. After we get the approval for the implementation, we go on a programmatic basis and actually implement the program. So in the case of lighting, we will work with our purchasing organization to leverage a buy across 25 plants to reduce our product cost. We'll develop plans and specifications for installation so that we can distribute to the plants to get competitive quotes on installation costs. And then we go ahead and get the projects done. After it's done, we document the results on that, and then very importantly, recognizing the results. So that is taking the teams that worked hard to be able to pull this together, recognizing them for their contribution to the organization, and continuing and encouraging activities to find ways to continue to reduce energy in their facilities. Now we talk about organizational support. The folks in this room range from a single proprietor, perhaps of a single plant, to a global organization with a lot of footprint. So they're going to vary. Maybe your support organization is one person. Right? Could be yourself and maybe a plant manager, an engineer, and that's about all you've got. We may have a corporate energy office, corporate real estate or facilities, or a facilities group that deals with the plants or your operations on a regular basis. I see a good theme of this conference has to do with lean manufacturing, continuous improvement, so you may have folks involved in Six Sigma, continuous improvement programs, or other folks in your organization that are focused on improving operational and efficiency in the organization. In this case, the best business practice organization is something that Johnson Controls has, and they're engaged in this as well. If you don't have these, there are outside resources available to you. A number of them. You have energy service companies that are in the marketplace. Johnson Controls happens to be one, as one of our business, but there are multiple options you have there. There are consulting engineers that you can bring in and hire to do an analysis and do an engineering study for you, and you can contract them to develop specifications and have this done. And those costs, given the payback, can also be justified as well. And then performance contracting firms. Let's talk just a brief. I'll talk about performance contracting a little bit later. And that's how, and when I talk more about funding. So how do you go about getting funding? You can go one project at a time, where we submit a request for spending based upon a return or what it will do for the organization. How many folks in here currently utilize that way of getting funding for their projects? Okay. Our organization does also. Another method is division-wide funding based on return on investment and the understanding that there's corporate responsibility to do that. We happen to do that as well. Are there any folks in here who do things on a division basis or on a consolidated basis across their plants? So there's a few. Then, in this case, where we found a tremendous impetus for change and acceleration in the attention given to this is where we've set a corporate objective. In the corporate objectives, we set goals for cost or GHG reductions, and we talked about the reductions offset to increase. We offset those to the increase in production. So as we continue to drive reductions, in our case trying to reduce greenhouse gases, as we continue to grow and build our business and add more facilities, it provides a dual challenge that says how do we continue to add to our footprint and in the growth of our company and maintain or lower our greenhouse gas emissions. Funds are allocated at CEO, CFO, it could be the president level, it could be a plant management level, it could be a single business owner. But you can set the objectives, we define what's it going to take to be able to get the investment. I was very encouraged to hear people have payback requirements now going to 2 to 3 years. It's a far cry from where we've been. Industries in distress, our automotive industry, when we were working on this last year, the return on investment was 1.5 years. Because, I don't have to tell you all about the state of the North American automotive industry, but they still continue to make those investments. We talked about alternatives to capital. Another way is performance contract is one way, and whether you go and contract this out through financing or you take it out of an operational budget, the basic premise is you have a budget today that includes your energy costs and your maintenance costs for your facilities. By making improvements, it will reduce the costs of maintenance and energy associated with that. And the savings that are driven repay the investment that you make. So in the simplest terms, when you're going to fund something out of an operating budget, you say, okay, I'm going to pay for this. Perhaps I have an increased cost in my first year based on my investment, but overall I'm going to my utility costs and my maintenance costs, and it's going to pay for itself over a period of time. Case studies. Before I get into that, any questions about what we talked about Yes.
Does your corporation set a goal for CapEx spending relative to capital investments in energy-related projects? Is it 9%? Do you set a goal of 5%?
We set the goal for reductions.
Understood.
Right, and so right now what we're doing is the challenge is to say, where are we going to go and get it?
So you don't as a corporation say, we're going to commit 5% of our CapEx spending to energy? Okay.
At this point, we do not.
And then one other question on do you also set a goal for green energy on electricity? Do you set a goal we're going to buy 5%, 10% of our electricity from a green source?
No, we don't. Yes.
Can you give some examples of your maintenance savings that you associate with some of these?
Sure. I'll get into that some of the case studies here. Okay, we talked about lighting retrofits. This is something we just recently completed across multiple divisions of the company. We retrofitted metal halide lights. How many people know what those are? Okay, those are big round lights that you normally see up in the ceiling of a manufacturing plant that, the bulbs last forever, but the light continues to diminish over time. That's a pretty old technology and pretty inefficient technology. We have that type of lighting in 99% of our manufacturing plants that are more than 2 years old today. So that's a lot. So when we went through and did the analysis, we made the decision that the best technology to replace that with was fluorescent lighting, the new T5 technology, and then we use variations between 4 lamp and 6 lamp fixtures depending on the light that we need. This is the results of the completed projects. AE is automotive experience, building efficiency, power solutions. And this was just projects we completed in the last year. The bottom line is we invested $6 million. Our annual savings is 3.2 million tons of CO2 emission, 23,000 tons of CO2 emissions reduced. Simple payback on that, less than 2 years. Yes?
Did you work with a particular vendor or supplier in that, or did you have multiple people working with you to do that internally?
So I have some folks in our organization that are focused on doing this. They did the research, interviewed a number of manufacturers. They made some decisions based on the technology. We competitively bid between multiple manufacturers and then selected the supplier based on their pricing and their ability to deliver on our schedule. To deliver this level of investment in a matter, so let's assume that that materials were a third of that. So for a single manufacturer to deliver $2 million worth of product within roughly an 8-month period of time, we had to be very careful about the ones that we chose as well. Part of the maintenance savings that we did not include in this calculation were the ongoing maintenance associated with maintaining lights of various ages and stages of life, because we track how much we spend in terms of lighting maintenance repairs in our plants, so we're able to define the costs associated with that. And understanding when you put all new lighting in, your lighting maintenance is going to drop dramatically for probably the first 4 years of life of those new fixtures. So we calculated that in as well. Okay. So we talked about measuring the results, measuring the data. We happen to take readings before and after of the amperage draw across our lighting circuits. You see before we were running up in this level, and one of the things I really want to point out is you see the variations in the line. Okay, that's harmonics and that's distortions in the power that we see coming through those lighting circuits. And you can see with each day that we did the installations, the consumption dropping every day to our installation. So you can see it took us 3 days to install it in that given plant. And we established a new baseline. The other thing I want to point out is you don't see the variations now in those lines, because installing the new technology also had a side benefit of improving our power factor and our harmonics within the plant, which means we're also using our power more efficiently. Here was when the plant was shut down. This happened to be 4th of July. This happened to be the normal 1-week shutdown that the automotive industry goes through in July. So we were able to document that. In terms of the savings, these were 3 lighting circuits that we used, and you can see 150 before, 43 afterwards. So we have the totals before and after and the difference. So we're able to calculate voltage, kilowatts, and this was the way that we came up with our calculations. We had the basis hours of annual hours of lights burned, which stayed the same. We had the electric cost per kilowatt hour that we're paying at that plant. We have the projected savings in the CAR estimate was 85, actual was 116. So our dollar savings at the basis, when we originally submitted the pilot, was at 46,000, actually ended up at 63. Our savings as a percentage went from 52% to 70%. 70% reduction in utility cost for an improved lighting result. Yes?
Can't quite read your light cost per kilowatt hour.
7.2 cents. So the project cost was estimated at 107. It came in at that. Our projected payback initially was 2.1 years. It dropped it to 1.7. Based on these results, we went back, readjusted for all of the other plants, submitted for approval, and gained approval to do the implementation.
Did you experience any other side effects of the new lights?
Yes. Yes, we did. On the plus side, a greatly improved lighting quality on the floor. Downside, people walked up in the plant and they saw a dark ceiling. So it was just kind of a visual impact that if they went up to see how are my new lights looking, they look up, they see more dark, they thought, oh, I must not have enough light, until they looked down on the floor, which in this case, before we had so much light being reflected upwards that it would tend to light up the ceiling. Now all the light's down, right? And the response we had is, well, how much work do you do on your ceiling inside the plant? Right? And it was, well, we don't do any, so let's take a look at the light on the floor. Yes?
What was the basis of the decision between T8s and T5s?
We looked at a difference. We looked at basically energy efficiency versus cost, and then maintainability as well. Okay, so many plants went with T8s, some went with 8-footers. We happened to go with 4 because we felt that we looked at it's a lower cost of replacement, and then if you have a lamp that goes out, you still have plenty of output from the 3, and you don't need to immediately go replace it. You can replace it on your own schedule. So here's another example was in our battery plant, our power frame innovation. This happened to be innovation in a change of process. We used to melt our lead and make our lead for batteries in a batch process, one pot at a time, and we changed our technology to go to a continuous process. As a result, that change in technology drove tremendous reduction in consumption. You see the reduction in therms, the reductions in CO2, and drove an 18% reduction in greenhouse gas. So it's not all just about lighting and facility infrastructure, it's about how can you change your process to a more efficient process. This happened to be a very large investment that the corporation made, but the payback on it was tremendous. One of the things that we have going now is a project to reduce power, to a power conditioning program, which is different than a power factor correction process. Power factor correction, the typical application is you put a transformer on the line, balances the harmonics, and away you go. This actually conditions the power and modifies the way the power is coming in so you can use it much more efficiently in the plant, use less power, dramatic increase in reduction of, dramatic reduction in the cost of maintenance. Because we had varying power. Power has different spikes and phase interruptions and a lot of technical things that I let my engineer deal with. But the bottom line is we were having failures in PLC controllers and variable speed drives. After implementing some of these on the pilot, those interruptions went away. Yes?
Do you do that at the main point of use in the plant?
On the other side of the transformer.
At the main coming into the...
Yes.
In one location?
Yes, in one location. If you have one feed, then it's one apparatus. Yes? Okay, so I'm getting the high sign on time, so we have a few time for questions here. Again, this was the preliminary results of the preliminary findings. We're in the pilot phase right now, and as you can see, we had approval on an anticipated 2.5-year return on investment for this application. And like I say, we're in the middle of implementing that. Based on the results, we'll look at a widespread impact. Okay. In this case, at a project we did at our Denmark home facility, a little different take on this. This was a 40-year-old plant, boilers needed replacing, and we actually went to a change in technology and went to a biomass boiler complex. It's actually a cogeneration complex. So it was CO2 neutral. We used waste from the local forests. Our energy expenditure we reduced by 60%. Simple payback of 3.5 years. CO2 reduction of over 1,000 tons. Overall investment was $2.5 million US, and a simple payback in 3 years. So there's a variety of ways that you can get at energy improvements. What's next? We've got lots of things on the list. You can do these individually on a plant basis if you have a need, but on a programmatic basis, we want to take major impacts at a time. We're taking our best practices, sharing them with the rest of the world, and looking forward to be able to meet the goals, aggressive goals that we've set.
What is LEED?
So LEED is Leadership in Energy and Environmental Design. This is a rating scale that the U.S. Green Building Council submitted. It allows you to measure the sustainability of your facilities. And this is very wide-ranging everywhere, everything from the way you control erosion during the building, to how much recycled material, how much energy efficiency, how much natural daylighting, to come up with a scale. Yes?
Same question on TIO.
TIO, I'm glad somebody caught that. TIO stands for turn it off.
Cheapest couple lines the one you don't use.
Exactly, and that's the premise. But how many of you walk out of a room, don't turn out a light? I mean, how many of you have children, you're always after them to turn off the lights, don't leave the light in the house on? Well, the same thing applies in the manufacturing environment. So it's just an awareness program that can also deliver tremendous results. We talked about recognition. These are some of the things that Johnson Controls does. We recognize on a plant basis, on a division basis. We have quarterly awards, and we actually have a chairman's award where individuals or groups are recognized for their contributions and actually in a nice ceremony and a dinner, and are recognized for their achievements.
Do you have like the top three, or if you have 7 great projects in 1 year, you get 7 awards, and the next year maybe you have 15?
So generally, correct me if I'm wrong, Clay, I think for a chairman's award, each division has 2. The quarterly awards are much broader. There's typically 4 or 5 per quarter per division, and that's by region also. So you can recognize, in our case, we probably have several hundred quarterly awards that we give because of the global footprint. Okay. With the chairman's award also, I believe, comes an award of stock. So there's a significant financial reward for the top ones in the company as well.
No brand new cars?
We don't build those. Yes?
Have you done any calculation or training for people of the startup cost of a fixture, including the wear and tear on the bulbs, versus the energy savings, and have a break-even point that, you know, after X amount of hours or minutes, there's
Yes.
if you're going out and coming back in 5 minutes, don't worry.
Yeah, we've actually done that. We found that initially the thought was with the older technologies that your ballasts go quicker, your light bulbs go quicker. Anymore with the new technology, it's virtually insignificant. One of the things that we've done is we put the motion sensors in place of light switches. Right? You can turn them on and off, but after no activity in an office, after you can set it for 10 minutes, the lights go off. Right? So if that happens when I'm working intently at my keyboard, I just kind of wave my arm and the light comes back on if I even need it. We also make expensive use of task lighting. Transition back.
Great. Last slide. I know we've got -1 minute, so I'll just 6 key takeaways. Okay, what are kind of the key elements of success of our program? Getting that leadership commitment to sustainability is absolutely critical. 2, programmatic approach to energy efficiency. We would not reduce our footprint 3% a year if we waited for individual plants to recommend and try to get approval for energy projects. We have to do it at a division and business level. It's the only way to get enough efficiency to make a difference. Integrate energy efficiency with established initiatives. We have a very active continuous improvement program. Don't view it as a separate activity. Integrate it into the other critical Six Sigma or other types of activities. Review and approve the programs at an executive level. All right, it's just as hard to get a $10,000 project approved as a $3 million project. So better to get the bigger programmatic type projects approved, recognize the accomplishments, and share the best practices. Okay? Those are the 6 takeaways that we think have been kind of key to our success. And that ends our formal presentation. We got a question.
Yeah, when you save on all this money, it's great for the company's bottom line and everything, but is there any savings to go back to the employees for helping to save the company's money?
Actually, yes, we do have those. Many of our plants, we have what's called a gain sharing or profit sharing programs. So for every dollar employee suggestions that reduce costs, there's a certain amount that's returned back to them. And we have both individual recognition as well as overall team recognition.
I'd like to re-answer the question about the green power, by the way. You saw the biomass plant that we did. If we have $1 to invest, we're going to invest in the technology for our own plants. We don't want to be out buying RECs in the market, and we don't want to have to write checks every quarter to get green power. We would much rather take that money and invest in the capital to produce our own green power. So biomass, solar, wind, things such as that, we'd be much more apt to invest in our own facilities rather than try to purchase the green power. Not that that's bad, it's just our internal bias and being in the energy business, we feel like that would be a much better long-term investment for us. Question?
Examples or input on waste heat recovery? Do you guys?
Yes, we've implemented those. Typically that's done, we do those on a plan or case-by-case basis. In some of our operations, particularly our battery operations where we produce a lot of heat, we're looking at the opportunity right now to say how do we capture it, can we use some of that waste heat. So we've done that before. Simple things like capturing on a steam boiler, using the condensate to preheat the feed water. We've done some water-to-air heat exchangers to help do some tempering of air. And I think it's something you just have to look at a case-by-case basis. But it is another viable application. Anything else? Well, thank you for your couple more. One more.
I was just going to ask, are there reliable tables about environmental impact? You mentioned trucks delivering to your plant. I mean, how do we go about measuring environmental impact or operation?
Yeah. Best single source is the US EPA. The Environmental Protection Agency has a lot of very, very good information about that. They have e-grid data, which actually has emission factors.